We're now going to talk about two more types of functions and how to graph them with transformations. The first one that we want to look at is on the left here, y equals -2 times the quantity of x plus 1 being raised to the third power minus 4. Now, first thing we want to look at is what is the parent function of each of these graphs. If I'm looking at this first function, this power of 3 should help me determine what this graph is going to be looking like. Now, a basic cubic function, if I just looked at x to the third without any modifications, it's going to have a general shape like this. Down on the left side and going up on the right side. But we're doing three different things to this graph looking at our transformations. We have a -2 multiplying, which will affect the graph. We have a +1 on the inside of the parentheses, which will shift us. And a -4 on the outside of the parentheses, which will also shift us. So we're going to look at each of those individually. So the first thing I'm going to look at is what does this -2 do, or the multiplying by -2 on the outside do? It's going to reflect it over the x-axis. So this is a reflection over the x-axis. So instead of being up on the right side, down on the left side, it's going to flip that graph over, and the left side's going to be going up, right side's going down. If I look at the +1 on the inside, this is going to shift us to the left by 1 unit. And if I look at the -4 on the outside of the function, this is going to shift us down by 4 units. Okay, so instead of starting at 0, 0, we're going to be to the left 1, down 4, at -1, -4 for our central point of the graph. So once I know all of this information, I'm going to take it and put it onto our graph. I can start this graph to the left 1 and down 4 so that I can see where this graph is going. And from that point, I can draw our general shape of a cubic function. And because it was reflected, we're going to start by going up to the left and down to the right. And the more specific I can get with these points, if I plug in some more values of x, I can get more specific values of y. But this is going to be our general shape for this. Now, I also want to look at what is the domain, what is the range on this function. So domain describes our x values that can be on the graph. And looking at this graph, it goes forever to the left and forever to the right. So I would say it has a domain of all real numbers. Looking at the range, we're going to look at how far down and how far up does this graph go. And again, it has no restrictions. So I'm going to say that this has a range also of all real numbers. So we figured out what this looks like based on the parent graph and multiple transformations along the way. So let's take a look at the second function on the right. We have y is equal to the absolute value of x plus 2 minus 3. So a basic absolute value function, if I were just to look at the absolute value of x without any transformations, it's going to be a V-shaped graph, either facing upward if it's a positive absolute value, or facing downward if it were a negative absolute value. If I look at the other transformations that are happening, this +2 on the inside is going to shift us to the left by 2 units. And then if I have the -3 on the outside, that's going to shift us down 3 units. And if it was the opposite signs, if it was a -2 on the inside, it would go right. If it was a +3 on the outside, it would go up. So based off of these transformations, I can put a graph onto my x and y axis. I'm going to start with the shift left 2 and down 3. And from that point, I can go ahead and draw in the right and left side of my absolute value. Right side's going to come up this way with a slope of 1 over 1. So every one I go up, I'm going to have 1 over. And then on the left side, I can have the same thing with that same slope of up 1 over 1 to get something that looks like that. So based on that, and I can determine what the domain and range are as well. So I'm going to start with the domain. Domain is left to right, and looking at this graph, I have a domain of all real numbers because I can go forever left, I can go forever right. If I'm looking at my range, two ways I can write this. I can do it in interval notation and say the smallest y value on this graph is -3. The largest value would be infinity. Or I could write this in inequality notation and say my y values have to be greater than or equal to -3. And both are acceptable, just depending on what the instructions give you. So again, as we looked at these functions, we determined what was the parent graph, how could we shift it either left or right, how could we shift it up or down, and then did we have a reflection based on a positive or negative value in front of the function itself.